So, I'm going to show you how to use the tree diagram method to classify 1000 batteries into four outcomes using the given information. Let's think about this. So first, there are 1000 batteries, 1000 products. 1000 batteries are inspected, and I will divide them into domestic batteries and imported batteries. And we know that their proportions. So we already know that 60% are domestic and 40% are imported. That means out of 1000 batteries, 600 batteries are domestic and 400 batteries are imported. So because it's obvious, 60% of 1000, 60% and 40% of 1000. So it's simple. And then this is the first step. And we used the first information. And now we will move to this node. So go to the pile of domestic batteries. And I am going to classify those domestic batteries into defective batteries and non-defective batteries. And we know that 2% are defective among domestic batteries. Remember, 2% is the defect rate for domestic batteries, and all of these 600 batteries are domestic. So we can use that probability. 2% of 600 batteries, 2% is 12. So if you inspect 600 batteries, 12 uh, would be defective, and the other 588 batteries will be non-defective. They must sum to 600 because you are simply just classifying uh, the the batteries, right? So you divided 600 batteries into two piles, and we are going to do the same thing for the other pile. But here, you have to use a different probability because these 400, the remaining 400 batteries are imported batteries. And we know that the defect rate for imported batteries are is different. It's 7%. So you have to use 7% to classify this. So we know that 7% are defective. Then 7% out of 400 batteries would be 28. So if you inspect 400, 28 would be defective. And then the remaining 372 batteries are non-defective. So as you just see, we divided 1000 batteries into four categories, four outcomes. Domestic defective, domestic non-defective, imported defective, imported non-defective. You have the numbers. And of course, if you add all these four numbers, you will have 1000 again because it's simply classification. And now you may understand this as a frequency. You may take this as a imaginary data. So you repeated the experiment 1000 times and you have four different outcomes with this many times, right? So then from this uh, classification, how can you calculate the probability of defective batteries? Try this. So again, the point here is you have done the experiments for 1000 times and you got four different outcomes. And and now we are interested only in whether it is defective or not. What is the probability? try this. Pause the video and try this. Um, 3, 2, 1. The answer is 4%. The reason is, so first, we are interested only in the event defective, being defective. And this event includes two outcomes: domestic defective batteries and imported defective batteries. These two outcomes belong to this event. So therefore, the probability of this event is the probabilities for these two outcomes. And there are 12 and 28. So in total, there are 40 batteries. 40 batteries that are defective, regardless of whether it is domestic or imported. So therefore, in the end, out of 1,000, we had 40 defective batteries. Therefore, the probability is 4%. If you change these numbers into a table like this, then it would be easier to understand. We learned how to calculate the probability from the table in chapter 1. So we know we already have the table, so you can do anything. Then now what I'm going to do here is I am going to recover, well, like go back what we have done, and I will extract the essential formula from the idea of tree diagram. So we just learned that the probability of defective batteries was obtained in this way. Out of 1,000, there were 12 plus 28, 12 domestic and 12 imported defective batteries. And how did we get these numbers? 12 was calculated as 2% of 600, and 28 was 7% of 400, right? We are going backward. And then where did these numbers come from? 600 and 400. 600 was 60% of, let's say, put it this way, colored. So, right, you may rewrite that way. That's how we got it. And 600 is obtained as a result of 6% of 1,000. And similarly, 400 was calculated as the 40% proportion of imported batteries out of 1,000 batteries. Then 2%, 60%, 7%, 40% are the probabilities given in the question. 1,000, so you may change 2% into this, 60% into this, 7%, 40%. So those probabilities can be written this way. That's the probabilities given in the question as an information. And then 1,000 is an arbitrary number. This is what you choose, but it will be cancelled out. So denominator has 1,000 and numerator, every term in the numerator has 1,000. So they can be cancelled out. So then in the end, you get this. This is the formula we just obtained. This is a general formula that works in any general case. So think about this. So how can we interpret this? Probability of B is probability overall unconditional probability of B, and probability A given B complement are probability of A among group B. I will rephrase condition this way. Let's interpret the condition as a group. So then you may interpret this formula this way. The overall unconditional probability of an event or condition A or on event A can be understood as the probability of A in group B and this is probability of A in group B complement. And you have to take average of them, average of two conditional probabilities of A using the weights equal to the probability of the group. So if there are more, say, if there are more domestic batteries, for example, then the overall defective rate will be more similar, more closer to the domestic batteries defective rate. Otherwise, if there are more imported batteries, then the overall defective rate will be affected more by the domestic imported batteries defective rate. So as you just see, diagram explains exactly what uh, you you get here, right? So you classify, you classify the overall observations into uh, subcategories. But in doing so, we have to use unconditional probability first, and then divide the them subcategory using conditional probability. Okay, so this is how we obtain unconditional probability from conditional probabilities. Um, so here I explained on another slide. I just exactly I use the same phrase in the previous slide. So in the next, let's do it. So from the same numbers, let's calculate this probability, this conditional probability. It's conditional probability of domestic batteries among defective batteries. How how can you calculate this? Try this, and after done, then continue to the next video. I will stop this video here.